given f of x is equal to 1 plus sine of x raised to the x power, I want to find the derivative at x equals 3 pi over 2. We're going to give two solutions to this problem. The first one will be find the derivative normally, and then the other one is find the derivative using the limit definition. Okay, so I'm going to rewrite this as e to the natural log 1 plus sine of x to the x power, and now the exponent is going to come out in front of the natural log. So it's e to the x times ln of 1 plus sine of x, and now it looks good. I can find the derivative. So this is an exponential, so that means the derivative is going to be the same expression multiplied by the derivative of the exponent, which for this we're going to need the product rule. We have two functions. So the derivative of x is 1 times the second plus x times the derivative of ln of 1 plus sine of x. And then the derivative of sine of x is cosine of x. And I can rewrite this, well, e to the x times ln of 1 plus sine of x. That was originally 1 plus sine of x to the x. And we're multiplying that by natural log 1 plus sine of x plus x cosine of x divided by 1 plus sine of x. So if you want, you can distribute out the 1 plus sine of x to the x, and then this would cancel out. But it's really, I don't think it's worth spending time on that. So we can just go straight. So we know that this was a derivative. We can plug in 3 pi over 2 at this point, and we get that this is 0. So this step, I would recommend just plugging in the calculator. Okay, so now we found the answer is 0. Let's actually use a limit definition to see if we also get 0. Right, so I want f prime of 3 pi over 2, and we said f of x is equal to 1 plus sine of x raised to the x power. So the derivative using the limit definition is limit as h approaches 0. Instead of f of x plus h, x we chose is 3 pi over 2. And then minus f of x, which is 3 pi over 2, all over h. So I'm just going to plug in 3 pi over 2 plus h into f of x. And if I plug in 1 plus sine 3 pi over 2 to the 3 pi over 2 power, that's just going to be 0. And that's going to be all over h. So notice here, I have sine of 3 pi over 2 plus h, which I can write that as sine negative pi over 2 plus h, because 3 pi over 2 is equivalent to negative pi over 2. And going a step further, this is negative cosine of h. Okay, so we're going to replace sine of 3 pi over 2 plus h with negative cosine of h. Okay. So we have limit as h approaches 0, 1 minus cosine of h. Okay, and then we have 3 pi over 2 over h. At this step, notice that 1 minus cosine of h is less than or equal to 1, where h is close to 0. Okay. the other thing to notice is that the exponent here, 3 pi over 2, is greater than 1. So what we have is a number that's less than or equal to 1 raised to an exponent that's greater than 1. So for example, if I look at, let's say, 3/4 squared, how does that compare to 3/4? Well, this is 9/16, which is a little bigger than 1/2. Okay, so 3/4 is bigger than 9/16. So for numbers that are less than 1, let's say we have x, if we raise it to an exponent y, so here we'll say x is, the absolute value of x is less than 1, and we'll say y is greater than 1, then this is less than x. I should say that x is positive. So we can make an inequality here, and we'll say that 1 minus cosine of h over h, and we'll say 1 minus cosine h to the 3 pi over 2 is less than or equal to, limit as h approaches infinity, 1 minus cosine of h over h, and this is equal to the derivative of cosine at x equals 0, which the derivative of cosine is sine, and so the answer is 0.